Hello, this is the review of the Chapter 9 reading. We're going to be talking about the two-way ANOVA and the effect sizes for it and the confidence intervals involved. Now you're going to use a two-way ANOVA when you have two independent variables and a dependent variable. It's probably best to talk about this within the context of a specific example, and so I have one here. Our first independent variable is study method, and it's going to have two levels. People are going to study by rereading material, or they're going to study by trying to recall what they've read. So these are two different study methods, two different levels of the independent variable. The second independent variable is time delay. Some people are going to take a test 5 minutes after they complete studying, and another group is going to, another condition I should say, is going to take the test 2 days later. Now we're going to cross these two independent variables. So when you cross two independent variables, each with two levels, that means you're going to have 4 conditions. And so we have one group of people who are going to study by rereading and then take a test 5 minutes later. And then suppose we had 8 people in that condition, we would compute their average score, and that would be the cell mean for this condition. Then we would have another group of people, say another 8 people, who would try to study by recalling and then take a test 5 minutes later, and their average would be this cell mean. Then we have a group who studies by rereading but takes a test 2 days later, and all of their scores would be averaged to compute this cell mean. And then we have finally a group that tries to recall as their study method and then takes a test 2 days later, and all of their averaged scores would be this cell mean. You also need to be familiar with the term of marginal mean. This marginal mean is the marginal mean for 5 minutes. In other words, it is the average of these two cell means, at least when these two cell means have the same numbers of people in them. It's always the case that this marginal mean would be the average of everyone who took the test 5 minutes later. And this marginal mean would be the average of everyone who took the test 2 days later. This marginal mean would be the average of everybody who studied by rereading. And this marginal mean would be the average of everybody who studied by trying to recall. And of course, the dependent variable is their test score, and that's what we're averaging in each of these cells, right? So if somebody got 10 out of 10 or 10, or I think this test is going to have 15 questions. So if somebody got 15 out of 15, their score would be, 15, of course. If somebody got 13, then their score would be 13. We're just averaging these to get these cell means and marginal means. Now, a two-way ANOVA is actually going to provide 3 different hypothesis tests. One is going to be something called the main effect of factor A, or the main effect of study method in this case. And I'll talk more about this in the next slide about how that is compared. Another test is going to be the main effect of factor B, or the effect that time delay has on exam scores. And then finally, the interaction. How do study method and time delay interact to affect exam score? What I have here in this table is basically all of the data. So we had 8 people who who were doing rereading as a study method and took a test 5 minutes later. So these are their 8 scores out of 15. This is what they got. And then this is the average, and this is the standard deviation of this cell. And then, of course, over here, this is the marginal mean. So this is the average of all of these numbers here. And then so on. This is the average of all of these numbers here. this marginal mean is the average of these numbers and these numbers, and so on. More about the logic of the two-way ANOVA. As I indicated, you're going to have three different ANOVAs, three different F values eventually that we will convert and get a p-value for. And each of these two-way ANOVAs, each of these ANOVA effects are similar to a one-way ANOVA in that they're comparing the amount of variability that a given factor creates, and then stripping away from that variability created by individual differences and measurement error. So for the F value for studying method, you're going to have the amount of variability created by the different studying methods of rereading and recalling. Of course, that is contaminated by individual differences and measurement error. So we need to strip that away, and we do that by dividing the amount of variability within conditions, which is created by individual differences and measurement error. And this numerator, of course, is the amount of variability between conditions. And of course, between conditions, there's different people in the different conditions. So there's individual differences variability, and there's always measurement error. But between conditions, we have different studying methods. So part of the variability created between conditions is due to studying method. So again, if you divide the within variability into the between variability, you're going to be left with some value that represents the amount of variability created by the studying with different methods. As in the previous chapter, if you get the null hypothesis will be that that this F will be close to 1 because in theory, if the null is true, the amount of variability created by the studying method would be 0 if they're equally effective, and so you would get an F of 1. It's very similar logic with the time delay. The numerator is the amount of variability created by time delay plus individual differences of measurement error, and then within group variability is again individual difference of measurement error. And so really what you're doing is you're comparing the amount of variability created by a 5-minute time delay versus a 2-day time delay. And then if the null is true, that variability would be close to 0, and then you would get an F value close to 1. Of course, if you get an F value a lot greater than 1, that would indicate that there is some variability created by these two different conditions, and then you'd want to analyze it to figure out which group is better, and so on. And then finally, you have the interaction. The interaction is often the most interesting effect that you're interested in studying when you do a two-way ANOVA. It's exploring the possibility that maybe the answer of which studying method is the best depends on another factor. So maybe if you're going to take a test in 5 minutes, a certain study method would be better. But if you're going to take the test after 2 days, a different study method would be better. So the interaction explores the idea that certain conditions influence what is better in one situation versus another. It's called an interaction. This interacts with that to affect the dependent variable. Now, this next slide, I'm going to explain specifically what numbers are compared with each effect that's being tested. So here is the conceptual equation for the main effect of study method. And as I said in the previous slide, the numerator has in it the amount of variability created by the different studying methods, but it also has individual differences and measurement error in it. So literally what we're comparing is this mean of 6.5 to this mean of 7.13. The greater these two marginal means are for again, the study method main effect. The greater these two means are different from each other, the bigger their difference, the bigger this numerator would be, and you'd have a better chance of getting a higher F value. Of course, you're going to, what this numerator actually is, it's not literally the mean difference between these two. It's more complicated than that, but it's a measurement of the between group variability between these two things. So the main point here is, for studying method, we're comparing these two marginal means. The greater their difference, the greater your F value would be. For the other main effect, the main effect of time delay, it's a similar idea. We're comparing these two marginal means. And again, the larger their difference, the larger the F value will be. Again, it's not literally just a mean difference. It's more complicated than that. But the larger that they are different from each other, the bigger the mean difference, the more the bigger the F value will be. Now, finally, the interaction effect. So the two main effects compared the marginal means, but the interaction is comparing the difference between cell means. So, and that difference is called a simple effect. So an interaction compares pairs of simple effects. So if you look at the simple effect for 5 minutes, when people were rereading and the test was 5 minutes later, they recalled 8 out of 15. When they were trying to recall and the test was 5 minutes later, they recalled 7.25. The difference between those two on that row is the simple effect of 0.75. We also generate a simple effect for the 2-day delay condition, and that simple effect is -2. The negative is important. You need to subtract the same direction. So 8 minus 7.25 is, 8 minus 7.25 is 0.75, and 5 minus 7 is -2. So what the interaction is testing is the difference between these simple effects. These simple effects are different by 2.75. This is 0.75 on the positive end. This is -2. So that means they're different by 2.75. The larger this difference, again, the bigger the F value will be. And again, larger F values will generate smaller P values, which will generate more compelling evidence against the null hypothesis. Again, the null hypothesis in this case would be that this simple effect and this simple effect are the same. And so what we're testing here is to get a P value to see if this deviation, the difference between 0.75 and -0.2, how likely is that deviation to occur due to sampling error. Now, I jumped into the example right away, but I want to review the procedure here so that we can talk about it a little bit at the end when we do our scientific conclusion. The research question that we're interested in studying here is how do study method and time delay affect test performance? So that's really notice we have two independent variables, study method, time delay, and the dependent variable is test performance. This is a pilot study. We just have 8 people per cell. That's way too small to actually do a real study with. However, pilot studies are a great idea because it helps you refine your procedure. Maybe by doing the pilot study, you'll discover, oh, I really need to use somewhat different stimuli, or I need to improve my instructions so that the participants understand what they're supposed to be doing. I need to maybe have a better test because my test didn't measure things as well as I wanted. So a pilot study will help you fine-tune your procedure. And that's what we're doing here. We're going to randomly assign participants to one of 4 conditions. Some people will study by rereading and then take a test 5 minutes later. Some will study by rereading and take a test 2 days later. Some will study by trying to recall information that they've already studied and then take a test 5 minutes later, and then another group will try and study by trying to test themselves by recalling again, and then take a test 2 days later. And of course, the dependent variable is their test score. Now we're ready to jump into actually generating some statistical evidence. And of course, the first step is hypothesis testing with a continuous p-value. And in this case, well, in all cases, we want to choose the correct test statistic. In this case, we have 2 independent variables, and we're really interested in see how they interact to affect a dependent variable. And so a two-way independent ANOVA is appropriate. And I say independent ANOVA because we have different people in the different conditions. There is an ANOVA and a two-factor ANOVA, or two-way ANOVA, where you could have the same people in the different conditions, and that would be a within or dependent ANOVA. We're just covering the independent ANOVA in this chapter. Specifically in the scenario that we just talked about, we're comparing the test score mean, the mean test score of each of these different conditions The next step is to examine the statistical assumptions. These statistical assumptions are identical to what we've described several times in previous chapters, so I'm just going to move on to the next slide. The next step is to identify the statistical null hypothesis, and in this case you're going to have 3 different null hypotheses because you have 3 different tests that are coming through. You have a study method null hypothesis, you have a time delay null hypothesis, and then you have an interaction null hypothesis. The study method null hypothesis is that the marginal means are going to be equal. Again, if the marginal means are equal, they're going to generate no variability between them, and the numerator of the f and the denominator of the f will be about the same value, so you'll get something close to 1. Similarly, with the time delay null hypothesis, these 2 marginal means will be equal to each other if the null is true, and then you'll generate an f value close to 1. And then the null hypothesis for the interaction is that the difference between these 2 cell means, the simple effect, is very close in size to the mean difference between these 2 cell means, which is this simple effect. So the simple effect of these 2 is equal to the simple effect of these 2, is the null hypothesis for the interaction. Again, if that's the case, you'll get an f value close to 1 for the interaction effect. Step 4 is graphing the data. Now I've graphed 3 different graphs here, one for each of the effects. This is the graph for the interaction. These points are the cell means. So the interaction graphs the cell means. Now, if you look at this, you can tell that when the time delay was 5 minutes, there's not very large a difference between the studying methods of recalling and rereading. There's a lot of overlap between these 2 confidence intervals. However, when the time delay was 2 days, it looks like recalling was a better study method than rereading. This difference looks more compelling. There's much less overlap between these confidence intervals than these. This is an indication that we may well have a compelling p-value for the interaction. If you look at it, it looks like you have 2 different stories to tell. If I ask the question, what's the best way to study? Well, at 5 minutes, you might say, well, it doesn't matter that much. They're pretty similar. However, at a 2-day time delay, it looks like trying to recall is much better than trying to reread. So that's what you mean by an interaction. If the answer to the question is what's the best, the answer is it depends. That's an interaction. And it looks like that's what we're going to get here. simply looking at the graph, it kind of looks like we have an interaction because, again, we have similar findings here. These means are pretty similar, but these look like they deviate more than would be expected by chance. Of course, we'll need a p-value to figure that out for sure. Now, when we come over here to look at the main effect of study method, these means are these points are marginal means, and it looks like there's a lot of overlap between these confidence intervals, so I would not expect a very compelling p-value here. When we look at the main effect of time delay, it looks like there's perhaps a chance of a more compelling p-value here. There's not as much overlap here between these confidence intervals. And it looks like as time goes by, people tend to remember more after if the test is in 5 minutes than if the test is 2 days, which of course makes sense. We know as time goes by, people forget things. So this wouldn't be too surprising in effect. Step 5 is computing the 3 f-tests and interpreting each of their p-values. Now, I'm not going to have you compute these f-values from scratch or from raw numbers. Instead, I'd like you to focus more on interpreting the information you get from computer software. Regardless of what computer software you're using, you're going to get an ANOVA source table that looks something like this one. You're going to have a line for each effect, and on that line you'll find the f and the p that you need to interpret. So let's start with interpreting the main effect for study method. Again, that's comparing the marginal mean for rereading and to the marginal mean for trying to recall. And this f value is 0.9. Again, if the null is true, we expect to get something close to 1. So this f value is not very compelling, and that's reflected by the p-value that it generates. A p-value of 0.3 is not very compelling. So that's telling you that these two marginal means, this difference, is very likely to have occurred due to sampling error, or certainly there's not compelling evidence that these two studying methods generated different test scores. So the next thing is to look for the main effect of time delay. That's comparing these two marginal means. And you can see that this f value is 6. That is quite a bit larger than you would expect due to sampling error. Again, if the null is true, you expect something close to 1 for the f value. 6 is obviously much greater than 1. So that means this mean difference is probably compelling, and if you look at the p-value, it is. So that p-value is suggesting that this mean difference is very unlikely to have occurred due to sampling error. So it looks like overall people remember more after a 5-minute delay than they do a 2-day delay, which again isn't surprising. As time passes, we forget things. We all know that. Now it's time to look at the interaction effect. We could look at the p-value or the f value first, and again it's 4.5. Again, we expect to get something close to 1, so this is quite a bit larger than that. The p-value is compelling. You get a p-value of 0.04. Again, what this is telling us is that these simple effects are different. This simple effect of 0.75 and this simple effect of negative 0.2 are different by 2.75. And that difference is unlikely to have occurred due to sampling error according to this p-value. That's telling you that you have a significant interaction. That says that the answer to the question, what is the best way to study, what is the best studying method, depends on the time delay. In order to interpret this interaction most accurately, you should do simple effects analysis. Again, you're going to get this from a computer, but you need to know what these numbers mean. So the simple effect for 5-minute time delay is comparing this cell mean and this cell mean. The rereading after 5 minutes, or excuse me, studying and then taking a test 5 minutes later, and then rereading, taking a test 5 minutes later, that difference of 0.75, this p-value is telling you that that mean difference is not very compelling. It could very well occur due to sampling error. So in terms, when there's a 5-minute delay, there isn't compelling evidence that one studying method is any better than another one. However, the story is quite different when it comes to a 2-day time delay. In that situation, the mean difference of 2, that simple effect, has a p-value of 0.04, which is compelling, suggesting that trying to recall things as a study method when the test is 2 days away is a more effective studying method. And so when we interpret the interaction at the end, when we do our scientific conclusion, we're going to want to comment on, well, at 5 minutes, there doesn't seem to be much of a difference between the studying methods, but at 2 days, trying to recall is a much more effective studying method in terms of it's not likely to happen due to sampling error. When we talk about how much more effective it is, we'll need to talk about the effect size, which is in the next step. Now it is time to talk about the effect size, or the practical importance of these things. You have a number of options. You can talk about the partial eta squared or the omega squared. You also could talk about the mean differences between the means that were being compared. So either the mean differences between the marginal means or the mean differences in the simple effects. We'll first start by talking about the partial eta squared and omega squared. If you can, it's good to use omega squared rather than partial eta squared, because omega squared is a more accurate estimator of the effect. Partial eta squared tends to overestimate the size of the effect, and you can see that reflected here when you compare them. Omega squared is always going to be a little bit less. When you talk about the interaction, the omega squared is suggesting that it's somewhere between a medium and large effect. The study method effect, omega squared is giving us a negative value when we compute it. And when you get a negative value, a lot of times computer programs might compute it as 0 or report it as 0 because logically it doesn't really make sense to talk about a negative effect in this context, in omega squared context. So lots of times people will report it as it's computed, but lots of times they'll just, if it comes out to be negative, just report it as 0. Obviously, that's a small effect. When you're talking about the time delay effect, the omega squared is saying that that's a large effect. I mean, it's pretty close to 0.14, so that's a large effect. You can also talk about the effect size by interpreting the mean differences. If you're talking about the interaction, you would be talking about basically just the simple effects, interpreting the size of the simple effects. You can also sometimes convert them to a percentage. In this case, that's easy to do because they took a test that was out of 15. So you just take the simple effect and divide it by the number of correct answers that were possible to get a percentage. So when the time delay was 5 minutes, it led to about a 5% better performance for rereading. But again, the previous significance test indicated that this difference was likely or could well have resulted due to sampling error. So while a 5% change might be large enough to have a practical importance, the previous test suggested this effect isn't reliable because it wasn't unlikely to due to sampling error. It was still well within what we'd expect due to sampling error. So when you get that pattern of results, when you get something that surpasses practical importance because of effect size, but yet it didn't offer a compelling p-value, that tells you that your sample size was too small. And that's not surprising. We only had 8 people per cell, And again, this is only a pilot study, so that result is not surprising. It means we're going to have to be pretty competitive or conservative when we interpret these results. It doesn't look, I mean, a percentage of 5 might well have practical importance, but because the effect was unreliable, we don't really know how to interpret that. We probably just need to run it with a bigger study, which is, again, what we're planning to do because this is just a pilot study. Now, we get an opposite effect with the day delay is 2 because now we get a case where we get a 13% higher performance for recalling. Clearly, that's a large effect. And this effect was reliably, statistically reliable in the sense that it had a very small p-value. Now we can look at the main effect for study method. Again, we're going to convert the mean difference to a percentage and find it's about 4%. This wasn't reliable on the previous slide. 4% might have practical importance. So again, indicating that your sample size is probably too small. For the main effect of time delay, we have a mean difference of 1.6, which is converted to a very large percentage difference. So that means that, again, people are remembering much more after a 5-minute delay than after a 2-day delay. Again, not surprising. The next step is estimating population parameters with confidence intervals. Now, we know we're going to get very large estimates here because our sample sizes are so small. But to just walk us through this interpretation, it's important when you're interpreting these confidence intervals around simple effects that you understand which way the simple effect was generated. In other words, which mean was subtracted from which mean. So it's important to note that. In this case, we subtracted the rereading mean, or we subtracted the recalling mean from the rereading mean. So that means a positive value at the end is going to mean that rereading had the higher mean. So with a 5-minute delay, the population parameter could be a benefit for rereading of 3.2 all the way to a detriment for rereading of 1.7. That's a very wide range when you're talking about a 15-point test, again, indicating that we have a small sample size. And we can do a similar interpretation for a 2-day delay, very wide range. It could be a benefit for rereading, or it could be a benefit for recalling. It just really depends on the sample size here. It's very wide. So again, you want to be very cautious when you interpret this. Now going down to study method, similar interpretation, pretty wide, could be a benefit for rereading, could be a benefit for recalling, pretty wide, want to be pretty cautious. The only thing that offers any kind of, I don't want to say certainty, but some confidence here is that you have a time delay benefit for, you have a time delay benefit for the 5-minute delay over the 2-day delay. And that's pretty reliable. You can see it could be as high as about 3 or as high as about 0.3. Of course, you want to talk about the methodology. In this case, it was a pilot study, so that's its biggest limitation. We know that it has a small sample size, so we don't want to draw any firm conclusions from this. It had some good methodology in it. We randomly assigned people to their conditions, and we had good procedural controls. You'd also want to comment in your scientific conclusion about the scientific literature. How does these results compare to those that you're aware of, and then offer an interpretation. Now, writing up a well-supported scientific conclusion for a two-way ANOVA is long in that you're going to need to describe 3 different effects. You need to describe the interaction, the main effect of time delay, and the main effect of study method. Now, which one of these you talk about first really depends on the results. In this case, you had a compelling interaction, so I would talk about that first. Anytime you have a compelling interaction, I would talk about that first. It's probably going to be the most interesting result. Now, if you did not get a compelling interaction, then you might talk about you would talk about one of the main effects first, whichever one happened to be more compelling. Now, if none of them are compelling, it doesn't matter which order you talk about. But the general rule of thumb, talk about the most compelling result first. Now, I broke this up across several slides because there's so much to talk about. This first paragraph here is describing the interaction, because again, I think that's the most compelling thing in these results. So that's the way we're going to start. We're going to start talking about that one. Again, you're going to try and fit in all of these components. First, we're going to talk about what we did and how. Then we're going to talk about provide the statistics, interpret the p-value, interpret the effect size. I'm not going to interpret the confidence interval right now because this is a pilot study. We know that they're really, really broad, wide ranges. So since we know it's a pilot study, I'm not really going to talk much about the confidence intervals in this interpretation. So tell what we did. We used a 2 by 2 factorial ANOVA, and I'm telling you what the levels of each independent variable were in parentheses, to test the joint effects of the IVs on exam score, the dependent variable. Then I'm providing the statistical information. I am also referring to table 1 that has the cell and marginal means and standard deviations. And then I'm also referring to the figure of the interaction. Now, I didn't include those on the slide because it was just too much information to get in there. But if you're interested in what those look like, of course, you can look in the chapter to see them. The next sentence offers an interpretation of the p-value, telling you that it's compelling for the interaction, referring to this, 0.04. The next offers an interpretation of the effect size. The results indicate that a 5-minute delay, the better exam scores in the rereading condition, is well within that expected by sampling error. So I did a number of things there. I'm talking about the simple effect now, and I'm interpreting the size of that simple effect. It was about 5%, and I'm saying that it was well within what was expected by sampling error because of this p-value, and then I provided this confidence interval here. So when you're interpreting the interaction, you want to talk about each simple effect, and that's what I just did here. When the time delay was 5 minutes, there were no compelling results. There was no compelling difference between the different studying methods. However, when the time delay was 2 days, there was worse performance when the people were rereading. And that's what I'm saying here. And that is compelling. And I'm saying that because the probability was not like it was not likely to be created by sampling error, which is what I'm saying here. And then I'm providing the statistics. So all of this is talking about the interaction. And again, in a complete write-up, you would have the table included and the figure included. This little paragraph is talking about the time delay. That's the next most compelling result. We found that time delay, 5 minutes versus 2 days, also influenced exam scores more than would be expected by sampling error. So I'm telling what I compared, and then I'm interpreting the p-value, and then I'm providing the statistical information. Now I'm talking about the effect size. Overall, those experiencing the 5-minute delay scored 1.6 higher or 6% or 10% higher than those experiencing a 2-day delay. And then I'm providing the confidence interval. The final paragraph deals with the main effect of study method, which wasn't very compelling, so that's why it's going last. I'm telling you what we compared. The worst exam scores for those rereading versus recalling, and then I'm providing the effect size, was within that expected by sampling error. That's the interpretation of the P. And then I'm providing the information of the statistics here. When the results were averaged across time delay conditions, there was no compelling evidence that one method was better than the other. That's my interpretation of that p-value. And then here is the confidence interval for that mean difference. Now finally, I'm interpreting the methodology and the scientific literature. The pilot study data justifies conducting a larger study to investigate the joint effect of studying method and time delay on exam scores. Drawing firm conclusions from the small samples used in the pilot study would be unwise, but an additional study with perhaps 30 or more participants per condition would allow stronger scientific conclusions. All of those slides would be, the information on all of those slides would need to be included to have a complete, well-founded, well-supported scientific conclusion.